Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 2.7. We'll hopefully complete this exercise in today's lecture. So, without wasting any time, let's jump into question number 10. So, for question number 10, they have given us two equations: y is equal to 2x squared plus ax plus 14, and the other equation is just the different form of the first equation. So, it's the by using the square method, they have already changed the form, and they're telling us that this is the change form of the equation. So what we have to do is configure the constants a and b, which have been given in this equation. First of all, we know there are two constants here, so it's going to be solved through a substitution method. However, how can we do that substitution? We compare these two values. For example, let me explain. We turn this 2x squared plus ax plus 14 into this form, which is actually this one. So either we convert the first equation into the form of the second equation, or what you can do is convert the second equation into the form of the first equation and then compare these two equations. For now, what I'm going to do is convert the first equation into the second equation. Okay. So for that, what we're going to do is, wait a second, write down 2x squared plus ax plus 14. I'm going to use the squaring method to take this into the other form. What we're going to say is, so we have done this in the previous exercises also, so it should not be as hard. What we preferably do is take 2 as the common for here, x squared plus ax upon 2. It's not necessary to factorize the common, so we are going to take it as a separate entity, plus 14. What we are going to do next is, again, open this up and turn this into the x minus ax upon 2 whole square, whatever it becomes. So what we do is 2 as the common, we have already taken, x squared plus a upon 2x. We have already discussed what we do in the squaring method. We take the coefficient of x and divide it by 2 and add its squared into the equation. If you're not clear about this, please do watch my previous lecture. Yeah, I've discussed this type of question just in the previous lecture. So it's going to be a upon 4 whole squared. And what we are going to do, as we are adding a upon 4 whole squared out of the a, we are not supposed to just add in it. So we have to subtract it also. So a upon 4 minus a upon 4 whole squared plus 14. Now what we are going to do is just really quickly solve this up, because we have done the tricky part. So what we're going to say is 2x plus, we take this coefficient a upon 4 whole squared. Wait a second, let me just, a upon 4 whole squared minus, what would that be? A upon 4 whole squared plus 14. Solving this further, we get 2x plus a upon 4 whole squared minus a squared upon 16 multiplied by 2. And we are going to add 14 into it. Now, the next thing what we are going to do is 2x plus a upon 4 whole squared minus 2 ones are 2, 8 is 16. So minus a squared upon 8 plus 14. It's upon you. You can take this, leave this as it is, or you could, take the LCM and do it all. I'm going to keep it, leave it as it is for now. Okay. So now we have the equation in the second form. What we do now? Now the thing is, we know from this equation that x minus 3 whole squared will come in the bracket in the form of a squared. Okay, which is being multiplied by 2. So if we compare the second equation, which has been given in the question, we say that the x minus 3 whole squared is quite similar to the x plus a upon 4 whole squared. So what we do is say that x plus 4 whole squared, sorry, x plus a upon 4 whole squared is actually equals to x minus 3 whole squared. And what we do? We cut down the squared on the both sides. We say x. In fact, we cut down the x on the both sides. So we, in the end, we get to say that a upon 4 is actually equals to negative 3. Then we multiply 4 by negative 3 and we get 4 multiplied by 3 is negative 12. So a is equals to negative 12. And that's it. That's basically what the comparison method did. You compare the values between the two equations, which remain the same. That's what we are doing throughout the equation. When we say b squared minus 4ac, we're taking the a value to be the coefficient of x squared, the b value to be the coefficient of x, and the c value is the constant. So that's what we are actually doing throughout the exercise. We're comparing with the coefficient of x squared, or there would be no coefficient. So that's it for a. For b, what we are going to do is we are going to use our a value to find out the b value. And that, how is that going to happen? We are going to take some space, or could I solve it here? In fact, I'm just going to erase from here. Okay, for b, we know that this part which is after the 2x plus a upon 4 whole squared part, we say that minus plus b and minus a upon 8 whole squared plus 14 are the same thing. Why is that? Because they are constants. A upon 8, a squared upon 8 plus 14 does not have a coefficient of x or x squared. It's not the coefficient of x or x squared. So same with b. It's not the coefficient of anything. It's a constant. So we compare the constant value. So we say that minus a squared upon 8 plus 14 is equals to b. We know the value of a, so it's going to be negative 12 multiplied by 12. Let me just find out the square root of 12. 12 multiplied by 12, which is equals to 144. So we are going to say that negative 144 divided by 8 plus 14 is equals to b, which would in return be equals to 18. Negative 18 plus 14 is going to be negative 4. And that's it. The answer for so the answer for B is negative 4. So A is equals to negative 12 and B is equals to negative 4. I hope the question is quite clear to you. If there are any problems, please do ask them in the comment section. For part B, what they've asked us the minimum value of y. Before we proceed through this question, let me just really quickly write the A and B values. So we know that A is equals to negative 12 and B is equals to negative 4. Now what they've asked us is the minimum value of y. Now we have already discussed, especially in the previous lecture, that when we get any equation in the form ax minus h whole squared plus k, we say that the h and k values are actually the stationary point. And what's the stationary point? It's the maximum or minimum point. Again, many students confuse themselves by saying they've asked the minimum value of y. What if the value would actually be the maximum value? Well, the thing is, there would only be one value. Either the value it's a maximum or a minimum. Obviously, you get a parabola, it's going to be either like this or it's like this. It's not going to be a hybrid of these two. Okay, so it's either going to be a maximum or minimum value. And when they say that the minimum value of y in the question, we already know by the fact that this is going to, wait a second, yes, I have some problem. So we already know that this is going to be the minimum point. Oh, sorry, wait a second, let me just change the color. Okay. Okay. So how do we find the minimum value of y? We say that a x minus h plus whole squared plus k. So what's the y value? K is actually representing the y value. And what's k? We already found out b. So the k is whatever b is, it's going to be the minimum value of y. So y is equals to -4. And that's it. We found the answer of the second part by the answer of the first part. It's basically not really hard, just simple. It's mostly about your concepts. If your concepts are clear, you're going to easily solve these type of questions. Okay, oops, my bad. For question 11, what they've asked us is find the set of values of m for which the line y is equals to mx minus 2, Cauchy curve y is equals to x squared plus 8x plus 7 in two distinct points. Okay, so what they're saying that these two lines cut each other at two distinct points. And we know for a fact when we get when we are cutting something at two distinct points, we say that the discriminant, which is b squared minus 4ac of both of the lines, is going to be greater than 0. I discussed the main concept why is that in the previous lectures. So if you're not clear, watch exercise 2.4 or 5, I guess. Yeah. So first step, what we do is substitute both of these equations. Mx minus 2 is equals to x squared plus 8x plus 7. Okay. So x squared plus 8x plus 7. Sorry. Plus 8x minus mx minus 2. Sorry. Plus 2 plus 7 is equals to 0. So x squared plus 8x minus mx plus 9 is equals to 0. X squared plus x as the common 8 minus m plus 9 is equals to 0. We get the values a is equals to 1, b is equals to 8 minus m, and c is equals to 9. What we do next, b squared minus 4ac, and we have discussed earlier that it's going to be greater than 0. So 8 minus m whole squared minus 4 multiplied by a, which is 1, multiplied by c, which is 9. And this is going to be greater than 0. So a squared, 8 8 is 64, I guess. Yeah. 8 8 is 64 minus 2 multiplied by 8 multiplied by m plus m squared minus 9 4s are 36. So we're going to say minus 36 is greater than 0. Simplify this equation, we get m squared minus 16m, and 64 minus 36 is going to be equals to 28. So it's going to be equals to positive 28. Wait a second. Is greater than 0. Now I'm going to use my calculator. Especially because which type of question is this? Okay. So it was part of paper 2-1. So it's we can use the calculator in this one. So what we are going to say is m squared minus 16m plus 28. I'm going to use my calculator to solve this quadratic equation. So it's going to be 2 and 2. So 1 minus 16 and positive 28. We get two values for m. We get m is equals to 14 or m is equals to 2. So these are the two values of m we achieve. Now again, we make a mini graph just for our easiness. We say what are the values which are greater than 0. So 2 and 14 would be something like this. So any value which is greater than, so and we would say that m is lesser than 2 and, or you can say m is greater than 14. So we would get, in fact, we would say that, yeah, or m is greater than 14. In fact, it's more better to say it in this way, that m is lesser than 2, but greater than 14. And that's it. This is it. This is the answer for question number 11. Quite basic. Again, it's more about of your concept than about your knowledge. Okay, for question number 12, what we're going to do is first of all copy down the equation. We've told us we have to draw the graph of a modulus function. So x minus 2 multiplied by x plus 3. And this is in a modulus. First of all, what we are going to do is, open this up. Y is equals to, I'm going to use my FOIL method right for now. So first is going to be x squared, outer plus 3x, inner minus 2x, last minus 6. We simplify this, it's going to be x squared plus x minus 6 in a modulus. First of all, what we do is find out the intersection points in this graph. How do we find out the intersection points? We just solve this equation by substituting 0. So x squared plus x minus 6 is equals to 0. We get x squared plus 3x minus 2x again minus 6. We just reverse opening it again. So is equals to 0. X as the common, x plus 3 minus 2 as the common, x plus 3 is equals to 0. We get two values for x. We get x equals to negative 3 and x equals to positive 2. These are the two intersection points of a curve. You can say this is one point and this is the other point. Next, what we have to find, the most important thing in a graph is its maximum or minimum value. Well, more easy, you could, one thing you could do, for example, was we have this equation x squared plus x minus 6. You could convert it into the squared form and then use the, would have compared it by a x minus h whole squared plus k. You would have done that. You would have compared it. It would have been completely correct. But there's a loophole. You can do it in a more easier way. What you can do is, we have the two intersection points of x. We know that the maximum or minimum point or the stationary point itself occurs at the midpoint of the two x values. So when we say x equals to negative 3 plus 2, what we do is find out the midpoint. We say negative 3 plus 2 divided by 2, which would give us, wait a second, negative 3 plus 2 divided by 2. Okay, so the midpoint would actually be equals to negative 1 upon 2, which would be negative 0.5. And that's it. Now we have the midpoint. What we're going to do is now find the y value for this corresponding midpoint. So we input this x value into the equation. We would get negative 0.5 squared vector as a whole. Negative 0.5 squared plus minus 0.5 minus 6. And if we would calculate this value, we would get 0.5 squared minus 0.5 minus 6. And that would give us negative 6.25 is equals to y. So this is the minimum point. So the minimum point is negative 6.25 and negative 0.5. Now what we are going to do is negative 0.5 is here, and we're going to assume that 1, 2, 3, 4, 5. Wait a second, it's not even. 1, 2, 3, 4, 5, 6, 7. And 6.25 is going to be around this point. So basically, if we would have drawn a graph, I would like to know what would be the value if we would have taken negative 5. So when x is equals to negative 5, we would get y is equals to negative 5 squared is equals to 25 minus 5 minus 6 and y is equals to 14. It's really high of a value. It's coming from above. So it's going to be something like this. And please do mind my drawing. I'm not going to add drawings. Going to come around here. It's really hard to draw in this way. I know it's really rough, but don't make it yourself. I'm making it in a by using a pen tablet, so it's really hard for me for now. So again, they told us to find meet the coordinate axis, and they also told us to find the stationary point on the curve. So we found the stationary point, which is here. Then they also is told us that given that k is a positive constant, state the set of values of k for which x minus 2, x plus 3 is equals to k has two solutions. First of all, before we solve this one, what we have to do is make this graph of what this equation is actually. So we know that this is a modulus equation. So whatever negative value will be here is going to be reflected by it. So 1, 2, 3, 4, 5, 6, 8. Again, I missed. N, 2, 3, 4, 5, 6, 7. It's going to be somewhere like here. And that's it. This is our equation, and the down part is not to be considered. Okay, so what they've asked us, find the value of k for it is a positive constant. State the values of k for which this graph is equals to k has two solutions. When it says two solution, it means it is going to give us two values. So find out from where we are getting two values. There are 2 points from where we are going to get two values. First is when when the y value is equals to 0. So y is equals to 0. And the second is when y is greater than 6.25, because 6.2 is 5 is the maximum point, and after we cross the maximum point, we are going to get only to intersection wherever we make a line. So we are going to say that we have two values for now. Y is equals to 0 and y is greater than 6.25. So what would be the answer for this? Given that it has two solutions. So okay, so we are going to say that k, and let me just erase some part so I can solve it out. So we are going to say that k is equals to 0 or k is actually greater than 6.25. And that's our answer for part number C of this question. And that's it. And this is it for question number 12. Proceeding on to question number 13. We have find the values of k for which the curve y is equal to 2x squared minus 3x plus k passes through the point 4 and -7. Really easy. What we have to do is just substitute the values. They're like 3 marks right now here. So question number 13, y is equal to 2x squared minus 3x plus k. Input the x and y values. So negative x is equals to 2 multiplied by 4 squared minus 3 multiplied by 4 plus k. Negative 7 4 is 16. 16 multiplied by 2 is equals to 32. So negative 7 minus 32 plus 4 3 is 12 is equals to k. To solve this as negative 32 minus 7 plus 12. Negative 27 is equals to k. And that's the value for the first part. For the second part, what they're asking us is it meets the x-axis at one point only. So again, when something meets the x-axis at one point only, we do know that the b squared, which is the minus 4ac, the discriminant, it is going to be equals to 0. So we already have the equation a is equals to 2, b is equals to negative 3. We take the coefficient of x squared, and we take the coefficient c as k. Oh, sorry, constant c as k. We say that b squared, negative 3 squared is equals to 9, minus 4 multiplied by 2 multiplied by k is equals to 0. So 9 is equals to positive 8k. And 9 divided by 8 is equals to the value of k when the when the curve meets the x-axis at one point only. That was really easy. No big thing here. They were like 3 marks for you. For question number 14, we have find the range of values of k for which the equation this, and this has two real distinct roots. So again, really simple. What they've told us already is that we have the equation kx squared. Just rearrange that equation. Minus 8x plus 2xk plus k. Done this plus k is equals to 0. Okay, first of all, what we're going to do is take the common kx squared minus x as the common. Wait a second. Yeah, x as the common. 8. In fact, what I prefer to do is take positive x as the common and take negative 8 in plus, oh, sorry, yeah, plus 2k plus k. So a is equals to k, b is equals to 2k minus 8, and c is equals to k. So b squared, which is going to be 2k minus 8 whole squared, minus 4 multiplied by k again. So we are going to get a squared, which is 4k squared, minus 2 multiplied by a, which is 2k, multiplied by b, plus 8 8 is 64, minus 4k squared. And again, they've told us it has two distinct roots, so it's going to be greater than 0. Okay, so when it's greater than 0, we cut down this 4k squared and 4k squared, we get a 2 is a 16, and 16 2 is a 32. So negative 32k plus 64 is greater than 0. We say that 64 is greater than positive 32. Okay. 64 divided by 32 is going to be greater than k. And we say in the end that k is lesser than 2. And that's our answer. Really simple. Just you have to substitute the equation and start again. It's the same thing repeated more and more multiple times. So no big deal. Okay, so question number 15, we have something similar. Find a set of values of x for which 4x squared plus 19x minus 15 is greater than lesser than equals to 0. So the first part is express this equation in the form of the squared form. So we have done this, sorry, we forgot the first part. So for question number 15, part A, they're just asking us to find a set of values for x for which it is lesser than equals to 0. And again, we have solved this type of questions throughout this exercise, so it should be a piece of cake for now. The 4x squared plus 19x minus 5 is lesser than equals to 0. It's a quadratic equation, and this question is part of paper 2-1, so that means you can use your calculator. It's short, so I'm just going to use my going to use the middle term breakdown. So 4 5 20 20 5 4s are 20, 2 2s are 4, 2 1s are 2, 5 2s are 10, 2 4 5, 20. Yeah. So 4x squared plus 20x minus x minus 5 is lesser than equals to 0. Take 4 as the common, sorry, 4x as the common, x plus 5, and then again take minus 1 as the common, x plus 5 is lesser than equals to 0. So we have got 4 x is equals to, so 4x minus 1 is equals to 0, x is equals to 1 upon positive 1 upon 4, and x is equals to negative 5. So in the end, what they've asked us are the values for x for which it is lesser than equals to 0. And we would get negative 5 and 1 upon 4. So we have to find the values which is lesser than 0 and actually the part which I am shading. So the point which is lesser than 0 for this equation would be x is when x is greater than negative 5 and lesser than 1 upon 4. And that's it. This is question number 15, part A. For part B, we have express x squared plus 8x minus 9 in the form this. Just we have to solve this and give it in a squared form. By the way, I'm really sorry. They've also asked the values which are lesser than equals to 0. So we're going to add equals to here. Because at these at negative 5 and 1 upon 4, it's the x value. You can say the y value is equals to 0. Okay. For part B, part 1, we have to express in the squared form. Again, we've done this type of question throughout the lecture. In fact, the last 2 questions were also based upon it. So what we are going to do is write down this x squared plus 8x minus 9. Again, x squared, take the coefficient of x, divide by 2, we get 4. Add 4 squared, but we can just not just add it in here. We had to subtract it to neutralize the equation, and minus 9. So x squared, sorry, in fact, what we're going to do is just take the squared we have added. So x plus 4 whole squared. Again, we take this positive or negative sign from the coefficient of x. If the coefficient of x is negative, we take it, we put a negative in this bracket. And if it is a positive value, so it's going to be a positive symbol in the bracket. So x plus 4 whole squared minus 4 4 is 16 minus 9, and we would get x plus 4 whole squared minus 16 minus 9 would become negative 25. And that's it. This is the answer. Simple. Not much of a worry. For part 2, what they've asked is use your answer in part 1 to find the greatest value of 9 minus 8x minus x squared and the value of x at which this occurs. And so what they asked us is they're telling us that so they've given this equation. However, they have multiplied it by negative. So whatever we have for the equation, x plus 4 whole squared minus 25, we take it and multiply it by negative. So negative x plus 4 whole squared plus 25. And what it does is, if you open this one, you get the same equation as this. As you can see, what's the main difference between x squared plus 8x minus 9 and the 9 minus 8x minus x squared? Difference is the second equation is being multiplied by a negative sign. So we convert our answer in part 1 to what we need by multiplying it by negative. So when we multiply it by negative, we can easily find the greatest value for this equation. Okay, now the thing is, when does the greatest value occur? First of all, I want you to look at this. The greatest value can only occur. Wait a second. Yeah. The greatest value for this equation can only occur when the answer for this x plus 4 whole squared comes out in the lowest value. Why? Why do I say it should come out in the lowest value? Well, the thing is because it's a negative. Whatever answer comes from the x plus 4 whole squared, it's going to be subtracted from 25. So if the x plus 4 whole squared is a minimum value we can get, it's going to give us the greatest value. Okay. For example, let me tell you, if I get something like negative, what would be the largest, smallest value I could get? So, for example, I get, in fact, 0. If I get 0 plus 25, we would get, I'm not saying it's right. This is the thing which is coming out from here. I'm just giving you an example. So negative 0 plus 25 is equals to 25. Okay. So the lowest the value, the highest the outcome, because that's how our structure is. Okay. So we have to find a way in which this x plus 4 whole squared is going to give us the minimum value. So we know for a fact that whatever value comes out of a squared, whole squared, it's going to be positive because negative 2 multiplied by negative 2 would become positive 2. Okay. So we would say that the minimum value we can get from a whole squared is 0, because before 0 we get negative values and after it we get positive values. So negative values can't come out from the whole squared equation. So we say that the minimum value we can get from x plus 4 whole squared is 0 dot. So when when does 0 occur? 0 does not occur for in this equation. However, we can say that we can take out the minimum value by assuming the x value to be 0. Because if we say, for example, x is 1, so 1 plus 4 whole squared is going to be 5 whole squared. It's going to be added into the value, which will give us a greater number. However, we need the lowest number. So then what would be the value? 4x for which we could get the minimum value. Again, I've repeated it. The minimum value we can get out of this would be 0. So what would be the value for x for which this would the whole squared bracket would become 0? So when x equals to negative 4, we'll say we get the 0 out of this bracket and we say 25 minus 0, which is equal to 25. So in this way, we have found out the greatest value of y we can get. So we can say that negative 425 is the greatest value of, for which 25 is the greatest value. And for achieving that value of 25, we have used x equals to negative 4. And obviously, you can say this is our stationary point. In the next question, they've asked us to sketch the graph and indicate the coordinates of any points of intersection with the coordinate axes. So just basically, we just have to build a graph. And for that, what I'm going to do, I've just plotted my points here. And basically, whatever points I got negative 425 here. I got the intersection of x-axis, which I found out here. So when y is equals to 0, I said 9 minus 8x minus x squared. Again, it becomes a quadratic equation. I get two values for x equals to 1 and negative 9. And then what I do is I find the midpoint. Okay. When I find the midpoint of these two x values, I get my stationary point, which is 9 plus 32 minus 16 is equals to 25. Again, I just did this part for confirmation of my stationary point, and this one was correct. Okay. So basically what I needed simply was just two coordinates of x where, or sorry, the two coordinates where the curve is intersecting the x-axis. So and y is equals to 0, x equals to 1 and 9. Yeah. Okay. Let me just open the graph paper. So this is my points. I've plotted them on my graph. And then what I'm going to do is just basically connect these. It's very simple thing like here. And that's it. This is the graph for question number 15, part 2. And that's it for today. If you want to highlight, you can highlight this point. And that's it. This is it for today's lecture. Thank you.